Hi, in this video, we continue our formal proofs in FOL and discuss the existential EElim rule. So if you read the chapter from the textbook, you should be able to complete this existential EElim proof. Why don't you pause your videos and then we will talk about the answer and what the structure of existential EElim proofs is like. Okay, that was your chance to try to figure this out. How do you go about trying to prove something from an existential? So the thing you should be noticing about this proof is that my premise is an existential. The fact that my conclusion is an existential is not what tells me what to do here. Whenever you know a premise, remember, elimination rules are for applying to things that you already know. It's when I know an existential that I want to think about applying the existential EElim rule to it. Okay, what do I do first? The structure of the existential EElim rule is one of the annoying ones. It requires a subproof. And it's similar in some ways to universal intro because it requires this arbitrary name device. But there's an important difference. When I declare that some name is arbitrary here, I need to put a formula next to my arbitrary name. So why am I doing that? What's going on? Well, think about what I know. I know that there exists some object in my domain with properties P and R. So when I declare an arbitrary name n, I do not want this to be an absolutely arbitrary object in my domain. That was what I did when I was trying to do universal intro. But I don't want to talk about that. I want to talk about this object here. I know that something exists that has properties P and R. I want to talk about what that thing is. So that's why I know that it has P of n and R of n, precisely because I'm following the structure of this existential. So when you do existential EElim, you first declare an arbitrary name like n, as long as you haven't used n somewhere else in your proof. Then you put a space. So there's exactly one space here. Now, I know that you never put a space inside sentences of FOL, but this whole thing is doing two things at once. This whole thing is not a sentence of FOL. In fact, this is declaring that n is arbitrary. And then this thing after the space, that is my sentence of FOL. This does have to obey all the syntax of FOL formulas. Now, what is the structure of this? It is exactly what's inside the scope of my existential quantifier with my arbitrary name n replacing the variable x's, whatever variable that was binding. And of course, notice that I dropped these outer parentheses because you never just have extra unnecessary parentheses around the formulas that you're writing of FOL, which would be down here if I have n's in for the place of the x's. So there's never a mystery as to what to put next to the arbitrary name n here. You always just follow this thing exactly and do those substitutions that I'm talking about. Now, how do you finish this subproof? What do you want down here? Well, that depends upon what your goal is. It depends upon what the sentence is that you're looking at. So let's see how I would try to get there. Well, I look at my main connectives. Once the main structure of my existential premise has told me what to do on line 2, I now need to look at the main connective of my new thing, the new sentence that I have, which is a conjunction. So that's why I brought down one of the conjuncts. Now notice, I now didn't bring down the other conjunct because I didn't need it. What I was looking at was I was looking at the structure of where I'm going. Remember existential intro. You know how to prove an existential sentence. You first need to just assemble the thing inside the scope of the existential quantifier. So that's why I proved P of n or Q of n here on line 4. Once I know that of object n, that it has P or Q, then I can existentially generalize. I know it's true of something. So the way the existential EElim proof works is I need to get on the end of that subproof whatever I'm trying to prove, which is my main conclusion here. It's a lot like disjunction EElim. Think about proof by cases. Remember when you knew a wide scope disjunction, the thing you wanted to end the subproofs with was the sentence that you're exporting. It was whatever your goal was. So this is kind of like proof by cases, just with one case. And if I can prove it just in this subproof, I can then export it out of here. Now, of course, I'm not using disjunction EElim. I'm using existential EElim because line 1 is an existential, not a disjunction. And when you cite it, you cite the existential that you're eliminating, and then a comma, and then the subproof, which of course uses that dash. So in this case, it's 2-5. So that is the structure of the existential EElim proof. Now, after you know this, you know all of the quantifier rules for FOL. So you've learned universal intro and EElim. And now you know existential intro and finally existential EElim. So the identity rules are the only things that you might not know yet. And let me just show you finally, we still have to talk about those identity rules, but the existential EElim rule, which we've been discussing in this video, here's the schema for it, or the abstract pattern. Whenever you know an existential sentence, that's what tells you to do the existential EElim rule. And to do it, it's this first line of the subproof is the key. You need to first declare an object as arbitrary, a name is arbitrary, like at n, then you need a space, then you need a formula next to it, which is exactly what's inside the scope of that quantifier, with the arbitrary name n replacing all of the instances of the variable that the existential was binding. Then finally, if you can prove some sentence down here, S, you're allowed to export it with the existential EElim rule. So in that sense, again, it's like proof by cases. It's like disjunction EElim, where you're doing some exporting. Notice this. Remember, here's my question for you. Can S have the name n in it? Well, you might think, sure, it could have the name n in it. After all, I proved P of n or Q of n in that previous example. But notice I did not export the sentence P of n or Q of n. Why? Because remember the constraint on arbitrary names. They're not allowed to appear outside of the subproof. But when you export a sentence with existential EElim, it's that exact same sentence that gets written down here. So, of course, the sentence S cannot have the name n in it, since it's written both inside and outside the subproof. If it had the name n in it, then it would violate the rule that the name n cannot appear outside the subproof. So that's why I do existential EElim. That's why I do existential intro first inside the scope of that subproof to get something which lacks the name n, which then I can, which is ready for exporting. Okay, so that's how the structure of the existential EElim proof works. Now what I suggest that you do is you find some harder examples to practice on. Okay, thanks.